Hey everyone, Mr. Voikin here, and this is Unit 8, Lesson 5. We're going to review from Lesson 4 and continue on expanding into the slope formula. So slope, part A, says is the measure of how steep a line is, so that's the measure of its steepness. And part B, the slope is a ratio of vertical change over the horizontal change, and quite often the vertical change is referred to as the rise and the horizontal change would be referred to as the run. And quite often with the vertical change we will say delta y, which means change in y, over delta x, which is change in the x. And it's often identified with the symbol lowercase m. Okay, just move this out of the way here. Line segment is going to be either positive or negative, so its slope is going to be positive or negative, and we always come from the left and then determine if it's going upwards or downwards from that point. So if we go left to right and it seems to go down, that's going to be, a negative slope. And if it goes left to right and then goes up, that would be a positive slope. Part E, horizontal line segment has a slope of 0, and vertical is what we call undefined. Now, if this question was on the test, the easiest thing to do is just to realize that if I have a horizontal line like this, and we'll call that line segment AB, and we're to look at the rise over run and recognize that it's not going up and down, so it's got a rise of 0, and the run would be whatever the distance is between A and B. So we'll just put, for example, 6 right here, and if I go onto my calculator and hit 0 divided by 6 and hit enter, it gives us an answer of 0. So every horizontal line is going to have a slope equal to 0. So we can do the same thing for a vertical line. So if I call this vertical line CD, and again look at the rise over the run and recognize that it is rising up and it's not going right to left or left to right, so it's got 0 run, and the rise is going to be whatever the distance of this line segment CD is. Again, an example would be 6, and if I go onto my calculator and hit 6 divided by 0, in this case, on the online calculator, it's saying complex infinity. On yours, it might give some type of syntax error, but it's not going to return a numerical value. So you know that it is impossible, and we call that undefined. Okay, and part G says the slope of all segments on a line are, and the answer would be equal. So what that means is that if I have a line with a slope and I go from here and go over and up and over and up and over and up to get back to the line, this x and y, x, y, x, y is always going to have the same ratio. So each one of those points are going to produce the same slope. All right, let's look at this section, developing the slope formula. So part A says, calculate the slope of line segment AB using the slope equals rise over run. So essentially, what I need to do is start at point A and go to point B right here. So how far up am I going? From point A, I'm going up 1, 2, 3. And how far over am I going? 1, 2, 3, 4, 5, 6. So it has a rise of 3 and a run of 6. and that's just basically a ratio or a fraction, and I want to reduce that down to simplest terms, which would be 1 over 2. Now I just want to point out that you don't have to use the two endpoints. Remember that all the slope is equal between any 2 points on the line. So if I was to choose this point and that point, notice that it goes up 1 and then over 2, which is what we determined for our slope. Okay, so part B says list the coordinates of the endpoints of line segment A and B. The coordinates for A are going to be 1 and up 8, and for B it's going to be to the right 7, so x is 7 and up 11. Part C, how can you determine the rise of line segment AB? Well, we've done this before. The rise is going to equal y2 minus y1. So I just need to label these 2 points, xy1, xy2. Doesn't matter which one is point 1 and which one is point 2, it will work out the same. Okay, so y2 in this case is 11, and y1 is 8, so we've got a difference of 3. So there is a vertical rise between A and B of 3 units. And for B, the run, it would be the same thing, except it would be x2 minus x1, which is going to equal, in this case, 7 minus 1, which equals 6, which is exactly what we ended up getting right up here in part A. So use the results from C and D to calculate the slope of the line. Well, again, the slope would equal change in y over change in x, which equals the rise over the run, which equals 3 over 6, which would reduce down to a positive 1 over 2. Okay, and it says part F says calculate the slope of line segment AB using the formula in E. Oh, I guess that's what I just did right there. What does part E say? Use the results from C and D to write a formula. Oh, okay, well I sort of did both of them there. The formula really would be like this. Let's see. Slope equals y2 minus y1 over x2 minus x1. Okay, and then the calculation would be exactly what I did to the right over here, except if we were to plug the values into there, into the formula that we just created, we would get slope equals 11 minus 8 over 7 minus 1, which equals 3 over 6, which equals 1 over 2. Okay, and calculate the slope of line segments CD using this method again. So I'm just going to do C. So basically the first thing I want to do is find the 2 points that are the value of the coordinates of these 2 points. So C is going to be 2 and 5, and D is going to be 6 and 2. Again, I'm going to label these as xy1 and xy2, and the formula is going to be slope equals y2, which is 2, minus y1, which is 5, over x2, which is 6, minus x1, which is 2, and that is going to equal a negative 3 over 4. And notice that I can't reduce that anymore, so our slope is a negative 3 over 4. Now, I just want to point out that this can be written 3 ways, negative 3 over 4, or negative 3 over 4, or we can actually write it as 3 over negative 4, but you hardly ever see it that way. But it's good to know that it can be like that, because remember, this value right here is going to be like the rise over run, and this is the rise over the run. So if we look at the first one right here, which is negative 3 over 4, and I was to go from point C, it says to go down 3. Okay, so down 3, and then it says go to the right 4, and that gets me to that point. Okay, now if I was starting at point D, and I was using this one over here, which is 3 over negative 4, notice that I can go, it tells me to go positive 3, so that's in the y direction up, and then negative 4, which is left in the x direction. So that gets me back to point C. Okay, so as we determined in the previous little section here, the slope formula is going to be represented by the lowercase m, and it's going to equal the change in y, which is going to be y2 minus y1, over the change in x, which is x2 minus x1. Okay, so class example 1 right here, it says to take these points that are given to us, these two coordinate points, and plug them into the formula. So this one right here, MGH, is basically saying what is the slope of line segment GH. And this one right here where it says YH, that is going to be the Y value at point H, and this is going to be the Y value at point G. This would be the X value at point H, and this would be the X value at point G. Now remember, it wouldn't make a difference if you went YG minus YH over XG minus XH. Just make sure if you're starting with H on the Y, you start with H on the X, and vice versa. Okay, so let's plug these values in. So the slope, oops, I'm just going to make that line a little bit thinner. The slope of GH is going to equal the YH is going to be negative 2. And if this was a test situation, I'd just take the time to write XY right there, just so you don't make the mistake. It becomes visual. So I'm looking for YH. Here is H right here. And sorry, right here, and the Y value is going to be the negative 2. Okay, so that's going to equal negative 2 minus, and the Y on G is 8, over the X2, which is going to be, or in this case, XG, or sorry, XH is going to be 7, minus the XG, which is going to be a negative 3. So make sure you definitely get that extra negative in there. A lot of times students will just go 7 minus 3 because it sort of looks funny when you put the two negative signs in there. And if we were to expand or simplify this, we're going to get negative 10 over 10. And reducing that down, we're going to get negative 1 over 1, which just equals a slope of negative 1. All right, moving on, we're looking at some new terminology, collinear points. So notice that in the first example right here, we've got a line going from A to B, and then another line going from A to C. They have different slopes, so we say that they are forming an angle right here. When we look at line segment DE versus FG, you can see that they have the exact same slope, except they're offset a little bit. So we say that they are parallel and distinct, which is indicated right here. And what about this line segment PR, which has a point Q? Well, in this case, we could say we've got three line segments that we could form here. We've got a line segment that would be called PQ. Just going to write that thinner, PQ. We've got a line segment that could be from Q to R, and we've got a line segment going from P all the way to R. So each one of these would have the exact same slope. Okay, and in that case, any point that is on this line would be referred to as collinear. Okay, so let's take a look at class example 3, and then we'll be moving on to the assignment. So prove that points A, B, and C are collinear. Well, what does that mean? Well, it means that the slope between A and B needs to equal the slope between B and C. If those are equal, then we know that this is all these points are collinear. So I'm going to start off with these 2 points, A and B, and I'll just call this XY, 1, 1, and 2, 2. And the slope for AB, so the slope for AB is going to be Y2 minus Y1 over X2 minus X1, which is going to be 6 plus 3, which is 9, over 2 minus 5, which is going to be a 3 negative, and 3 divided by 9 divided by 3 is going to give us 3 over 1, and that's going to be a negative slope, or you could write it as negative 3 and just assume that the 1 is on the bottom. Okay, so let's take a look at slope M of BC, and that's going to equal, now I need to create some new points, so I will just sort of delete this XY that I indicated there already, and I'll do it again, XY 1, 1, XY 2, 2, and this is going to equal Y2, which is 33, minus Y1, which is 6, over X2, which is negative 7, minus X1, which is 2, and that's going to equal 33 divided by, or minus 6 is going to be 27 over negative 9. And 9 goes into 27 3 times. It's going to be a negative slope, and we can see that these are the same. In that case, they are referred to as collinear. All right, there we go. We're going to move on to the assignment, which starts right here on page 532 and goes all the way to 536, and the answers are also on page 536.